the review and everything real quick.
Okay, we will do. Okay.
Amanda, so how was, I don't think we asked you about it, but how was the flood yesterday?
Yeah, did it affect you?
Thankfully it didn't. Like, it affected every single apartment around me, and I'm on the first floor in Royal Crest. I don't know if you know where that is, but,
I'm trying to think. Is it by the stadium?
yeah, kind of. It's, like, right across the street from the Hart Building.
Okay, yes.
And so everywhere was completely flooded. Like, bunkhouse got 3 feet of water, and I'm on the first floor, and we didn't get any water at all.
Hey, that is so lucky.
Yeah. Yeah, and I actually drove in it a little bit when it was just beginning, so it wasn't as bad. But
Wow.
Yeah, we saw pictures and videos that our family was sending us, and Andrew was like, we didn't even ask Amanda if it affected her.
yeah.
So did any of your classes get canceled or anything?
No, I only have classes on campus on Tuesdays and Thursdays, so I didn't have classes today.
Oh, that's nice.
Yeah.
Okay, we're ready when you are. Have you looked at it at all?
What?
Have you looked at the review at all?
I looked at it really briefly. My internet's been going really slow.
Okay.
So
I looked at it earlier a little bit. I had 3 papers doing another class today, so I was kind of working on that. But I did look at it. Does it look? Do you think that the test 5 is going to be, or the last test, is it going to be like over everything we've learned?
yeah, I think it's cumulative, so it's gonna be over everything.
Okay.
So,
I was hoping it wasn't going to be, but
yeah, at least that's what I kind of.
Group meeting.
That's what I got from what what the teacher put in the course instructions and
okay.
stuff like
Is
that.
It looks. I mean,
Is
looking
this-
at this, it
this
looks
is- this is
cumulative. This is a test review.
We only have one more test, right?
Yeah.
This is it.
Yeah.
The test, and then that's it. And then the project, and then we're done.
Yeah. Which, thank you for editing that paper. Sorry, I had so many mistakes.
Oh
Yeah.
no, it's okay.
Read over it. Usually I do editing, but I didn't
Yes,
read over
I'm
it,
not
so.
very good at paper-wise. Andrew's usually the one that does that. And he didn't do it because he had to work today. So, but thank you for looking over that, and then I submitted yours.
Okay, cool. That's
Okay.
good.
Started. We got our notes. I think that's that. Yep. That's starting here. Okay.
Oh, it'll be over.
Do you want to read the?
Wait, I almost have the quiz opened. My internet's just being.
No, sorry. You let us know.
Okay.
So you're going home for the 7-week break?
Yes. It'll be the first 7-week break I've ever gone home.
Oh, really?
Yeah. Yeah, I've been here 2 7-week breaks before, and pretty much the only reason I'm going home this time is just so I can have help planning for the wedding and everything.
Yes. That's exciting. So are you flying home or are you driving?
I'm driving, and I'm actually driving my fiance's car because he left it with me, and it stick shifts. So
You gotta practice then,
get a lot of practice first.
Yes. Yeah, I'm not good at driving stick at all.
Yeah, I'm terrible at it. Like, sometimes it goes really well, but then other times it dies like 5 times in a row.
Yeah, I couldn't do a stick car.
I have it opened now. So,
Okay.
do you want me to read the first one?
Yeah, do you want to go with number 2?
Okay. Which of the following variables are quantitative? So, quantitative means numbers, so there'd be the number of people in a randomly selected classroom on campus. So it'd be, or I can't remember what the telephone one is. That one?
I don't think it is the telephone number of a randomly selected business. No.
So it would just be A?
Yeah.
If it was the telephone. Yeah, not the telephone number. The number of
telephone numbers.
Yeah.
Okay, that's what it was. Because I remember there was a question like that in a past exam review, and then we got it wrong because there was like confusion with it. But
Okay.
that makes sense. So just A.
Okay, Andrew, do you want to read 3?
Students in an introductory statistics class at BYU, Idaho were studying prices of cold cereal at a grocery store in Rexburg. To get a sample of cold cereal prices, they went to Albertsons and rolled a die to decide which box from left...
Sorry, I'm going to stop you. Are these the same questions that we have had in the past?
I don't know if they are.
I just remember reading something about this. That's why. Okay, sorry, keep going.
Left to right, down... Which box from left to the top shelf they would start on. They then recorded every 6 cereal after the first, moving from left to right down the shelves, recording the name, size, and price of it. In this study, an experiment or an observational study, and why experiment? Because the students had control over which sampling method they used. An experiment.
Wait, so they recorded every 6 cereal after the first. Okay, so then...
They then recorded every 6 cereal after that, moving from left to right down the shelves, recording the name, size, and price of each cereal in their sample. Is this study an experiment or an observational study, and why?
Okay, so experiment because they have control over the sampling method? Because they didn't have control over which cereals would be selected.
Oh, yeah. Right. Yeah, I would say A.
Okay.
Okay. So, for Math220 Project 1 group of students studied the ages of students on BYU Idaho campus. They collected data from a random sample of 100 students. The sample mean was 21.2. The sample standard deviation was 2.61. An excerpt of their data is given below. The group notices an error. The age of the male, 3D,
He's actually 21 years old.
Yeah. With this error, what will happen to the sample median? Won't it increase?
The sample median.
Yeah, will increase.
Wait.
Not the sample mean.
Oh, the median.
So the median is just the middle
Middle
one.
number.
If it's 21, you would go 18.
20.
So hold on. 12.
It stayed the same because it's going to be 21 or 21. Well, no.
That's what I'm saying. Let's write it down real quick. So you get 12.
So the median...
20, 21, 25. Then you'd have... Where's the pen? The median is just the middle number.
Right.
12, 18, 20, 21,
It would
25.
increase.
So it would be it'd be 20 if it was that, and then it would be 18, 20, 21, 21, 25.
Yeah, so it would increase.
Or do you only write down?
And if it's two numbers, then you add them together.
You mean there's just one? Like that? You don't add them.
Well, if there's two middle numbers, then you add them together and divide by 2.
There's no two.
Okay, so then it would increase because it'd go from 20 to 21.
But what I'm saying is, do I write down 21 twice or 21 once?
21 twice.
You agree, Amanda?
So we're saying the median would increase because they increase that number?
So if you write it out with the 12,
So
you'd go 12, 18, 20, 21, 25. And with that set of data, it would be the median would be 20. But then if you switch it and do 12 to 21, it would
because
go
12 is out.
18, 20, 21, 21, 25, and the median would then be 21.
Okay, yeah, that makes sense. So the median will increase.
Okay. The time to complete a standardized exam in the BYU Idaho Testing Center is approximately normal with a mean of 70 minutes and standard deviation of 10 minutes. Using the 68, 95, 99.7 rule, approximately what percentage of students will complete the exam in under 50 minutes? Give your answer accurate to one decimal place. Okay.
So under 50 minutes, 70. So then that would be two
So-
standard deviations.
Yeah. So wouldn't it be the
So
9.7?
wait. So 68 is one standard deviation, 95 is 2, and then 99.7 is 3, right?
Oh, yeah, so 95.
Yeah, so 95% rule.
Point one, right? Because it says round to the decimal
Hey.
place.
Wait.
You go like this. This is the one standard deviation. Second, and then third. And this is 65,
68, 95,
68,
95, 99.7.
99.7. So it's asking approximately what percentage of students will complete in the exam in under 50 minutes. It'd be
So wouldn't it be 95.0? Because if we're using that rule, we have to either do 68, 95, or 99.7.
so. Let me ask this question: is it 95% from 50 and above? Because if the question's asking if it's below 50, then would it be 99.7? Makes sense?
70.
Because the standard deviation is 2 standard deviations away, and it's 50. And 50 is the mark for the 95th percentile, right?
Right.
But it's not asking what is 50%. It's asking it says who will complete the exam in under 50 minutes. Right?
I don't know.
But then, I don't know, because that's confusing, because 50 would be 2 standard deviations, but then
Because it's all the people.
under 50,
It's all the people within that gap.
so maybe it is 99.7.
I have no idea.
Well, no, because
Because it's not
Well,
yet.
I would
Yeah,
think
not
that
yet.
it's 95 because it's...
I would stick with 95.
Okay. So then we'd put 95.0. since it wants us to do 1 decimal place.
Yeah.
Okay, the scores on the LSAT are approximately normal with mean of 150.7 and standard deviation of 10.2. Queen's School of Business in Kingston, Ontario requires a minimum LSAT score of 157 for admission. Find the 35th percentile of the LSAT scores. Give your answer accurate to 1 decimal place. So, we need an equation for that, right? Fine.
The
Yeah. And then it says use the applet.
Okay.
So we just type in into the area 0.35. Is that what we do? We don't remember. Was it this one? Lesson 9, inference with 1 mean, sigma known. Yeah. Oh, because we don't.
Do you guys know the website for the normal probability applet?
Statistics.byui math.com.
Okay.
Try that.
Nope. That did not work.
If you go to the textbook and go into the main page and go under resources, it's right under there as well.
Okay.
Do you have the calculator, Andrew? It was on the scriptures on the table. Oh.
Got 42 problems.
And then for this one, are we shading in the left? Because they need, wait.
Minimum else. I would say the right.
What did you get for your answer?
For the z-score?
Yeah.
My z-score is 0.618 rounded.
How did you find that?
So, it's back in, if you go to Lesson 8 review, it's in Lesson 5. Z-score is the value minus the mean divided by the standard deviation.
So yeah, so you took 157, right? Minus 150.7
Yeah.
divided by 10.2.
Yeah.
Oh, okay. Now I got a normal number. Sorry.
Okay.
And before it was way off. Okay, and then we just round it, right, to 6 or 0.618.
Yeah.
And then I would think that we would.
Find the 35th percentile of the LSAT scores. So 35th percentile would be the least half.
Yeah, yeah.
So maybe.
So shade the right. Oh, shade the left.
Yeah, so only shade the left and then leave the right and middle blank.
Well, what if you shade the middle?
So then it would be 0.268.
Wait, so we don't need to shade the middle?
Well, it said it requires a minimum of 157. 35th percentile. So, let me look at this.
Does it say anything? I'm trying to look in chapter 8 about.
Yeah. So in lesson 8 for that review, there's like they use the 10th and 90th percentile, number 27 and 28.
But not the 35th.
But not the 35th.
Okay, well, let's go into the next one. We'll put in 0.2683.
But then it says round to 1 decimal, so it would be 0.3.
0.3, yeah. Okay, so for number 7, a team of dermatological researchers were studying skin cancer among 60 to 70-year-old American men. Suppose you were part of the research team and take a sample of 70 men from this age group and calculate the mean number of skin spots in the sample. Also, suppose it is known that the distribution of number of cancer spot is right skewed. So suppose the sample size for this study was 2. What would be the shape of the distribution mean? It either be left or we cannot be sure.
So it says, suppose you were part of a research team and take a sample of n equals 70 men from this group.
Yeah.
Calculate the mean number of skin cancer spots. Also suppose the distribution of the number is right skewed. Suppose the sample size for this study is just, it gives us 2 sample sizes.
Yeah, so it's saying that the larger sample size is right skewed. So the smaller sample size either is going to be left skewed or we cannot be sure without examining the data.
Well, I think it would be we can't determine it because we only have the sample size. We don't have any other information.
Okay. Okay, so Andrew, do you want to read the next one?
Tanker trucks are designed to carry huge quantities of gasoline from refineries to filling stations. The factory that manufactures the tank of the trucks claims to manufacture tanks with a capacity of 8,550 gallons of gasoline. The actual capacity of the tanks is normally distributed with a mean of 85.44 gallons and standard deviation of 12 gallons. Use this information to answer question 8. A simple random sample of n equals 20 tanks will be selected. Find the z-score corresponding to a sample mean capacity for 20 tanks of 85.41 for 2 decimal places.
So would we, for the z-score, would it be similar to what we did before, but instead of dividing by the standard deviation, would we divide by the sample mean?
Okay, this one, we have to do the value minus the mean, and then that number divided by the standard deviation divided by the square root of the sample size. So that's in lesson 7.
So we would go 8544.
Wait a second. Get a calculator. I need to get a. Okay, so we're doing the value minus the mean. So that's 8544. Wait.
Would it be 8550?
Yeah, 8550 minus 8544.
Divided by 12 times the square root of 20.
So then it'd be divided by, yeah, 12 divided by the square root of 20. So I got 2.236.
That's what I got as well.
Okay. I really feel like we've done these questions in past assignments.
I know.
These all look the same. Like deja vu.
So would we shade in?
So this is, wait, so the sample size changed, so then our z-score changes, right?
For
For number 9, our sample size and our
yeah.
two numbers change, our sample size and our value.
Yeah, so we would go 8540 minus 8544 divided by
12 divided by square root of 50. So I got negative 2.357.
Yep, I did too. Negative
357.
2.357.
So then I forget, on this one, do we only shade the right or do we shade the middle and the right?
Oh, because this is wants the probability, huh? Where the other one wanted the z-score.
Yeah. So it's the probability that it will be greater than 8540, which is the value.
Well, wouldn't we just shade the middle and the right? It's greater than?
Yeah, I think so. Be greater than. Yeah. If we do that, I got 0.991 rounded.
Yep, that's what I got as well.
Okay, the significance level of a hypothesis test. So that was.
Assuming the null hypothesis is true, the levels.
I feel like we just did this on one of our.
I know. That was on a different review.
Yeah, and I think we got it wrong. I'm gonna go look at our last.
We did 3 exams so far, so I think that was on exam
Level of significance.
2.
A type 1 error. That's what it is. Because we said the probability of obtaining a test is that it would be straight. I think it's A.
Yeah, we did. Which of the following best describes the notion of a significant level of hypothesis, or no?
Of the significance of a
Hypothesis
the
test?
significance level of a hypothesis. And it's that.
Okay.
Significance.
If you go to the textbook, in lesson 9.
Would it be C? It's either C or D, right?
No, it's the probability of a type 1 error.
Oh.
So if you go to the textbook, it says assuming the null hypothesis is true, the level of significance is the probability of getting. Oh wait, right here. In other words, the level of significance is the probability of committing a type 1 error. And I remember talking to him on the phone about that.
Yeah, we emailed him about that question.
Oh yeah, 'cause that was like question 13 last
Yeah,
time or something like
11.
that.
Yeah, I just went and looked. It's 11.
Okay.
Question 11, and yeah, I emailed about him about that one, and he said it's type 1. Okay, the height of a young adult female in the U.S. Are said to have the population standard deviation of 2.6 inches. A sample was taken of 85 young adult females at BYU, Idaho, and the mean computed as 65.4. Which of the following explanation describes the correct way to interpret the 95 confidence interval for this problem? Maybe more than one correct answer.
Isn't it? We are. We're 95% confident that the true mean height.
Yeah, we are 95%
No.
confident that the true mean height of adult females in the United States is somewhere in our confidence zone. That one, right?
Yeah.
There's a 95% chance that the true mean height. Or could it be both? It says may be more than one answer to the correct answer. 95% of all the heights of female adults in the U.S. What about D?
D A B. No, I don't think that one.
Because the question is the heights of young adult females in the United States. So the survey came from the United States, anyways.
But I don't think that means 95% of all the heights of female adults in the US are in our confidence interval.
The
Because
height.
that's talking about all the female adults in the United States.
Well, that's the question. The heights of young adult females in the United States are said to have a population standard deviation of 2.6 inches. A sample is taken of n equals 85 young adult females, so our sample size is 85, so it's large enough that it's a normally distributed.
Yeah, but would all of those different heights be within the confidence interval? Because the confidence interval is just
95% of all the heights. Um, confidence interval.
I think it would only be B or A and B. I don't think it would be C, D, or E.
Okay, we can go to the next one. My wife's changing Caden right now, so
Oh,
she'll be
okay.
back in a minute. But we can talk about it. But yeah, I don't really know for sure.
Okay. Um. Um. When was. What lesson was exam 3? Exam 3 was lesson 20. Okay.
Are you looking up for that question?
Yeah.
That's all.
Hmm. Yeah, I can't find it. Do you wanna? So, do you think it's just B or do you think it's A and B?
Uh,
Chance?
I don't know. We'll see what Brittany says right here.
Okay.
Okay,
I
sorry.
agree that it's B, but I just don't know if there's another one. So
I think it might only be one. Maybe it's a trick question.
the heights of young adults females in the United States are said to have a population standard deviation of 2.6. A sample was taken of 85 young adult females at BYUI, and the mean computed to be is 65.4 inches. Which of the following explanation describes the correct way to interpret the 95% confidence interval for this problem? May be more than one correct answer.
So you guys think for sure it's B?
Yeah. We're just trying to decide if there's another one. I want to say A too. And I said D, but I don't know. 95% of all the heights of female adults in the U.S. are in a confidence interval.
I don't
Of all the
know.
heights of female adults, because we are 95% confident that the true mean. What's the definition of a confidence interval? We have those. What does that mean? Do we have like a? Do you know what confidence interval?
I think it might only be B.
Yeah, I don't. None of the other ones, but I'm trying to look. Do we know what lesson it's from?
No.
For a standard normal distribution between what two z-scores will 95% of the data fall. So it says between the two z-scores will 95% of the data fall. In other words, find the value of z and v and such of the area between them is equal to 95.
Do you know, is this review going in order at all, or is it just random?
I
don't
have no idea.
Because we just saw something from lesson 7.
Okay, so if I go into a group meeting, it says, given a 90% confidence interval for the mean heart rate, which of the following best interprets this confidence interval? And the correct answer was we have 90% confidence that the true mean heart rate is between 95 and or between 45 and 105.
Yeah, so that would be B.
Okay.
For number
Go
11.
through the other ones.
I know, I didn't. I'm going down.
Yeah.
I'm gonna see if there's any other ones that talk about it.
What?
Okay,
Wait, what lesson was that from?
this is from exam 2 review.
Okay.
It says which of the following would produce a confidence interval? Oh no, that one. So maybe it is just B, because I'm not finding anything that's asking. Four types of confidence intervals.
Which of the following is 95% confidence interval? 95% all the data? I think we're good. I think we're good with B.
Yeah, I can't find anything else on it. Okay. So, Andrew, do you want to read the next one?
Marine biologists have been studying the effects of acidification of the oceans on weights of male beluga whales in the Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researchers want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follow a normal distribution. The population standard deviation of weights of male beluga whales is 125, and the researchers feel comfortable using a standard deviation for their confidence interval. Are the requirements for the use of this confidence interval met? Explain. Yes.
Wouldn't it be B?
It'd be A or B. Yes, the distribution of sample mean is normal because the data are normal. Yes, the distribution of sample.
Does it say that the data's normal? Yeah, their data.
But also
they're
our sample is normal. Or no, it's not. One of the studies involves a random sample of 16. So A.
A.
I think it would be B.
Well, our sample size is only 16.
A.
Is that considered large?
No, it's 30.
No, 30 or more. So yeah, it'd be A.
But right after that sentence, it says their data follow a normal distribution. So
Yeah.
we only know that it's normal because the data is normal, not because the sample size is
Yeah.
large.
Yeah.
So A.
Yeah. A.
Okay, Brittany, do you want to read 13?
Yeah. An investor with a stock portfolio worth several $100,000 sued his broker and brokerage firm because he felt the lack of diversification in his profile led to poor performance for many years in a row. In an effect to avoid public public scrutiny, the firm agreed to settle the conflict by um, a panel log. Okay. The S&P has a known population mean return of 0.95. Suppose that you are a member of this panel. Conduct hypothesis tests to determine if the investor profile performs significantly worse than the performance of the S&P 500. The level of significance is 0.05. Open the data file. Rate of return. Use the answer number 13.
Okay.
We would just do one sample t-test, right?
Yeah. Is that under quantitative descriptive statistics? Right?
Quantitative inference.
Quantitative inference. My computer's going really slow, so I might get the answer a little bit later than you guys.
No, you're okay. I'm still working on it.
Okay, so then we would be using less than because we're looking for if it's worse, right?
Well, it just wants to know the p-value.
Oh, right. Okay.
So I don't know if it matters.
Okay, so I got 0.128.
Zero. Yes, 0.128. Yep.
Okay.
We had this exact, number 14, we had this exact question before.
Really?
Yes, but I can't find
Where?
the one.
Oh, it's that's what I already
Yeah.
did. I did some. No, I just did some of it. It's the
D?
because so yeah because he wants to compare. He wants to compare. He wants to compare a couple's income, and so
Married couple.
a married couple, and so it depends. So when he chooses the husband, the
He needs a
wife,
wife,
the
too.
wife is already included in the sample, in the survey, in the whatever sample he uses. So it says dependent sampling. He needs to select couples for his sample. So whether a particular wife is included depends on whether her husband is included. Because I don't think it'll be in the other ones because independent sampling, they're not independent.
Right.
The two spouses are not separate, so that doesn't make sense.
So it would be D then.
Yeah, and the other dependent sampling says the husband's income depends to some degree on the wife's income, but it's not asking. It's not asking, or maybe he wants to compare the mean income earned by husbands with the mean income. I think it's D. But
Yeah.
I can pull up. I can see if we have it somewhere.
Well, it's not on any of the test reviews.
What's 13?
point.
I think there was something similar in the test review for exam 2.
Okay. Well,
So I think it is D. That.
You want me to read 15?
Yeah.
Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, airline raise their price. If seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. Ali Henrik, a BYU student, wanted to determine if there is a difference in the price of tickets listed in 90 days before a flight compared with 14 days before the same flight. For her study, she compared the prices of one-way flights from London's airport to various destinations in Europe. Using Travelocity.com, she recorded the lowest published fares for 90 nonstop midweek flights 90 days in advance, and then found the lowest published price for the same destination, again 14 days in advance. The prices in US dollars are given in the direct flight costs. Now, notice that for some destinations, flights are not available. Use this information to answer questions 15 through 16.
So we have to download that direct flight cost. Okay, so then would that be using the paired sample t-test? Because you're comparing the two flights?
Yes, I think so.
Yeah. So they're comparing the
So we're comparing 14 days to 90 days? Okay.
See right here.
paired sample.
Yeah, we're doing a paired sample t-test, right? Is that what we decided?
You want to, should we charge your computer?
Amanda?
Oh.
Amanda, are you there?
Oh yeah, I am. Could you guys hear me?
No.
Oh, can you hear me now?
Yeah.
Okay, cool.
You did a paired sample t-test, right?
Yes.
Okay. Did you get the p-value?
Almost. Okay, p-value is 0.096.
Um, I got something different. I got 0.403. Oh, but hold on, I did something wrong. Wait, what did you say you got?
0.096.
0.96. Yeah, yes. 0.096 is what we got.
Okay. And then that is greater than the level of significance. So we failed to reject.
So we get, is it C?
Wait, so we failed to reject the null since it was greater than. So it's asking, can you say that there's a difference? And the alternative was that there's a difference. So we would say no. So then you said C, right?
Yeah.
Okay, yeah, C.
Okay.
Okay, do you want me to read 17?
Yeah, that'd be great, thanks.
Okay. A real estate company wants to evaluate two of their home appraisals for consistency in preparation for the annual state certification. It is important that different appraisers be able to give similar estimates for homes and other properties. The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate for the home value. After they receive the estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ plot of the differences and see that the points in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? So the sample size is 10, so it's not because the sample size is large. And it's not normal because it's a straight line, so it doesn't have the bell curve. So I would say C.
Okay. Yeah, the distribution difference is not normal because the sample is not large enough. Yeah. Okay. Now suppose the company of the previous item wants to use a hypothesis test to determine whether the estimates given by the two appraisers are different. Which of the following would be the most appropriate pair of hypothesis for such a test? Yeah, it'd be A, right?
A equal to and not equal to. So they wanted to see.
Like two appraisers.
Yeah, I'd say A. Yeah, equal to and then not equal to.
Okay, suppose you create a 95 confidence interval for a mean and get negative 2.346 and 8.775. You've been told to report this by saying we are 95% confident that the true mean is between negative 2.346 and 8.775. Exactly what does this mean?
I would say D. 95% of the sample means are between those two numbers. Confidence interval.
Yeah, we never say chance.
There was one that we did say chance.
I don't think so.
Because the confidence interval has to do with the mean. So 95% of the sample means are between those two numbers.
So this is kind of what we reported above. It says we have been told that we report this by saying we are 95% confident that the true mean is between this and this. That's how we answered it above, because that's what it is asking us how we report it. So what does that mean? Does it mean 95% of the sample means? It's asking about the
Because like if you go in the Excel sheets and then you click on confidence interval for any of them, part of calculating the confidence interval, you have to know the mean.
Okay.
Yeah.
Yeah, I think it's that one. I think it's D.
Okay.
Okay, so if P is 5/4, what is the smallest value of N that satisfies the requirement for normal distribution?
I forgot how they did.
Well, it has to be 10, right?
Yeah, okay, what was
that?
there was okay, so it's N times P is greater than or equal to 10. So to find N, we have to do 10 divided by P. So
So 12.5?
wait,
Close the door, please.
okay, I got 3 wait, why is this? I got a decimal thing.
Did you get 0.5? Or what did you get?
I got 12.5.
Yeah, that's what I got. It's
Oh, okay. I thought you said just 0.5.
No, sorry, 12.5.
Okay.
Okay, hold on just a minute. Oh, maybe it's 12.5. Okay, next. Andrew, do you want to read the next one?
12.5.
Yeah.
Your little brother has a career batting average of .233. You want to determine the probability that he will have batting average over 250 next season when he will be up to that bat 40 times. Are the conditions met so that the sample proportion p hat will be approximately normal? What? They don't give us any information. Okay.
Okay, so
Sample proportion p hat. Yes, there is a large number. Proportion must be known.
Well, I think would it be B?
Oh.
wait.
I don't think it doesn't matter. It doesn't matter how many times he goes up to bat. It matters how many times he gets on base for his padding errors. So no p-hat can only be normal if the sample data are normal. So the data has to be normal, meaning that the results have to be, I don't know, because it can't be a yes, there's a large sample, so the sample proportion must be normal.
Yeah, it's not that one. And it's
But
not
it's not that one because,
either.
well, if it's not D, then it can't be B.
Well, it's not D because that doesn't equal 10. And you don't want it to be less than.
Okay.
Well, I guess if you read it though. Because it says it's less than 10, so the conditions are not satisfied.
So, average, you want to...
Are the conditions met so that the sample proportion p-hat would be approximate?
And
I'm going to find out. Maybe start talking about p-hats. Remember?
so 10. I think it would be B. Because if you do that equation, n times p is equal to or greater than 10, p 0.25 is p, 40 is n, and
you want it to be greater or less than.
yeah, and
Okay.
40 times 0.25 is 10, so I would say B.
Okay, perfect. Okay, do you want to read the next one, Amanda?
Yeah. A geneticist takes a simple random sample of n equals 140 gamete sex cells from the testes of a dog to determine the proportion which contain the chromosomes for development into a male. Assume the unknown true proportion of dog gametes that contain the male chromosomes is 46%. Use this information to answer question 22. The geneticist conducts her survey and calculates p equals 0.512. Which of the following is the most correct interpretation of this statistic? So that's p hat.
Yeah.
So the traditional estimator of p is p hat. P hat.
What did you say p hat was again?
Well, the book says it's the traditional estimator of p. I put, maybe, if I go to lesson 17.
Sample proportion p hat is normally distributed. The n is large. True population mean.
So yeah, P.
Okay, p hat is the sample proportion of. Okay, p hat is the sample proportion, but just p is the true proportion. So we're looking at the sample proportion with p hat. So
Would it be C then?
51 points. All the gametes and dogs.
No, or would it be? What's our sample?
I would say D because p hat is the sample. It's based on the sample proportion.
We had this same one too.
You did?
Yeah, we've had this exact question too. I don't know if the gametes are the same.
Where is it at?
This takes a simple random sample of 140 gametes from the testes of a dog to determine the proportion which contain the chromosomes for development into a male. Assume the unknown true proportion of dog gametes that contain the milk is 46%. Use this information to answer 22.
Okay, we had the exact same question that we just thought in 21.
And
21 batting average. I just found it on our other assignment, homework lesson 16, and the correct answer is actually D.
oh, that's what I said. A, B, C, D. Yeah, because p hat is the sample. It's
No, this for 21.
yeah, p hat is the sample proportion. So for 22 it would be D.
No, not 22, 21.
Wait, what's 21 is D?
Yeah.
Yes.
So then P was 0.233.
Yeah. And then for 22, it's also D.
Okay, yeah, 22 is D.
Yeah. We also had question number 23.
Alzheimer's disease. This is.
But we got it wrong. So let's see if we can get it right this time. We'll see.
I'll read it. Researchers published a study in which they considered the incidence among the elderly of various mental health conditions, such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the U.S., 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the 750 adults over 65 in the study suffer from one or more of the conditions under consideration. Give your answer accurate to 3 decimal places in decimal form. Is there a place that we have information, or we just have to calculate this in the probability.
Wait, what lesson was this question from?
16. 16 homework.
Okay, 16.
And then we also had number... Okay, sorry. Going back to number 17, I found this one as well in a homework assignment. And the answer is actually B. For number 17.
Yes, the distribution of mean differences is normal because it's determined to be normal.
Did the data happen?
Where did it say it was determined to be normal?
And then for 18, it's C.
Oh, so we just put the wrong...
Yeah.
We put 1 instead of D.
C, yeah. Okay, and then I also found 19.
Well, make sure that it does say that it's...
And 19 is B.
B?
Yeah.
Wait, 95% of all 95% call.
Yeah.
What the heck? Okay, so going back to...
Let me change that. I don't know, so go back before we found this one because it says yes, the distribution.
So, with the Alzheimer's disease one, for the probability I got 0.101.
Okay. Just a minute. I can't even remember, sorry. It's going to be...
Was that homework or is it?
Yeah, homework. I think it was 17 or 16 or 17 homework. Okay, so for the Alzheimer's...
Like, did you like it?
Okay, so for... Hold on, sweetie.
Wait, so we got 20 wrong then. Because number 20 was in lesson 16 homework, and I put 12.5 and got it wrong.
Okay, see, and we put 13 and got it wrong. So I don't know what it would be then.
So it's asking what is the smallest value of n? 4 divided by 5. I don't...
5.
Is p hat, does it have to be 10?
It's 5, isn't it?
Or does it have to be 5? Because I think p hat is different than...
Oh, wait a second. Okay, I think we were doing the equation wrong then. Let's see. It's... Because p hat equals x divided by n. So that means n would be 5? Wait, no, that's p hat. P equals 4 divided by 5. Let me see. What does P equal? n times p. 10 divided by... So, I don't know, maybe it is 5. That question's confusing.
So
Because it gives us p, but then asks about p hat.
So
I don't really know what 20 would be, so maybe it's 5.
yeah, so then what we would go 0.8. Would it be 7? I don't know. Because do you remember the requirements for p hat?
No. I'm trying to find it in lesson 20, because lesson 20 is the review for all of that. But...
Yes, but lesson 16, we had the exact same question.
Right.
Did
And
you see
so...
in there or no?
But I put 12.5 for that one and got it wrong.
Okay.
And then we wanted to put 12.5 this time, but that would still be wrong. Because, okay, it shows in lesson 18 when it's showing sample proportions, it's saying p hat equals x divided by n. So I think 20n would equal 5, because it's saying p equals 4 divided by 5. If it's not that, I don't know how we're supposed to get it.
You said, what is the equation for p hat?
P hat equals x divided by n, but then it shows us p equals 4 divided by 5, and p hat is the sample of p.
Oh, is this where you always, is it 13? Is it always where you always round up to the whole number?
Didn't you say you guys put 13 though and got it wrong?
Yeah.
Well, is it just, is it 1? 4 divided by 5 is 0.8. What was it? Let's put 1. Should we put 1?
Okay. Okay, well, we'll
I have
just
no
keep
idea.
going. I don't know. Okay, so for, what did you say you got for number 23?
23, 0.101 for the probability.
Yeah, that's what I got as well.
0.0.
Yeah. Yeah, 0.101, right?
Yes.
Okay.
24.
Suppose you're testing P equals 0.62 and P does not equal 0.62, and you calculate the test statistic and you get Z equals 1.334. The area to the right of Z is 1.34334 is 0.091. Which of the following is p-value of your height? Wouldn't it be B?
0.091. Oh yeah, because that's the thing where it's
Yeah.
yeah, B.
Okay.
Okay, 25. Suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution of X is normal?
Greater than or equal to
We
30 or
had
10.
we had this exact question on homework lesson 17. It says any n will do.
Is
Any N will do.
that because it tells us that the sampling distribution is normal for Cocker Spaniels?
Oh.
It is known that the distribution of fertility levels of Cocker Spaniels is normal. So it doesn't matter what our N is because it's already normally distributed. Does that sound right?
Yes. I don't know.
The study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. A sample of 41 men are taken with p-hat estimates for the true proportion of men who dislike anchovies was determined to be 0.67. A sample of 56 women was taken, and p-hat estimate for the true proportion of women who dislike anchovies was to be 0.84. Are the requirements satisfied to perform this hypothesis test? Why?
So,
When you have two proportion tests, is that the greater than 5? Which test was it?
Well, we have this same one too, and it says no because the sample proportion is too small.
The sample size of 56.
so then,
Then we're a sample size of what? 41.
Yeah, I don't know.
Go to that one.
okay.
I have
What are the
no
numbers
idea.
they're saying?
Okay, I would say B. Yes, because in both cases, N times P hat is greater than 10. Because the one for men is 27.47, and then the one for women is like over 40.
See, and that's what we thought as well. And I just looked back onto lesson 18 homework. We had this same one there. And
Wait, so So you put that in
Yes.
both cases and times, and then you got it wrong?
Yeah. It says the correct answer is no because the sample size for women is too small.
What? Why do they even give us that equation if it doesn't work?
I know. That's what I'm confused about. I'm like, I don't know then.
Wait, but how is the sample size of women too small? It's
I
over
know. Wouldn't
30.
it? I know. It's well, and it's bigger than the male.
Yeah.
So I don't get that one.
Some of these questions don't make any sense according to what we're supposed to be learning in this class.
Yeah, that's what I keep. That's why I keep checking. I'm looking to see. They're kind of going in order, so I'm going through the lessons homework, and majority of the questions are on there. And the ones that we're saying are what we think are pretty much the same ones that in my homework that I said, and they're saying that they're wrong. So I'm like, I don't know.
Whenever we get answers wrong, it should at least have an explanation because we're in the homework, we're using those equations, and then all of a sudden we take this test and then we're not supposed to use the equation anymore?
Yeah, I don't know. Yeah, I have no idea. Okay, do you want to read the next one, Andrew?
A study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for this analysis? UD is not equal to 0.
Yeah, I'd say B. Mu D is not equal to 0.
I would too.
You think so?
Yep.
Why is that?
It says on the other one.
Okay.
Is it?
Yeah.
Where is that at?
I'd have to go back. I'm on a new page now. And then, do you want to read the Weight Watchers one?
Yeah. Weight Watchers wanted to predict how much weight a client would lose if they followed a prescribed exercise program in addition to their diet program. Volunteers were randomly divided into two groups. One group dieted but didn't exercise, and the other group dieted and followed the exercise program. For the exercise group, they used linear regression with percent compliance with the exercise program as the explanatory variable and pounds lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. What does this mean? So the residual is that's the inference, quantitative inference. Linear regression, residuals.
Isn't it the predicted?
I put that in my notes somewhere. That was this week's lesson, wasn't it?
Yeah, yeah. Andrew, what is
The residual is the difference between the observed value of y and the value that would have been predicted.
Okay.
What's the question?
So then it would be B, right? Because his actual weight was 5 pounds lighter, or 5 pounds higher than his predicted weight loss.
Yeah, because, yeah, that would make sense. B.
For the study in question 30, The B1 of the regression line was 5 pounds. Interpret this statistic.
Okay. B1.
Okay, so B1 is the worst. We always look at it.
I think they're just right up front. No, they're in this one. They're in this notebook.
See if we can get any of this. Slope and regression. See what that.
So it's the slope. So therefore, wouldn't it be as a percentage compliance goes up by 1% on average, 5 pounds are lost every 3 months?
Hold on. I'm trying to figure out what B1 is exactly. Quantitative interest. B1 is the slope.
Yeah.
So yeah, I'd say C.
Okay. Perfect.
Okay. Number 30. When creating a scatter plot, a residuals plot, and a QQ plot, which of the 5 assumptions about linear regression are being checked? Did we just do this yesterday?
Yeah. But I think it was in the homework, and we can't. Oh no, it was this one. So it says there is a linear relationship between x and y. The residuals are normally distributed. And the variance of error terms. Yeah. It could be more than that too, though.
So I think there needs to be a linear relationship between x and y.
Yeah, that's what I got. There's a linear relationship between x and y.
And then
And the residuals are normally distributed.
right. And then
The variance of the error term.
uh-huh.
So we said the residuals are normally distributed. There's a linear relationship between x and y.
Yeah.
The variance of the error term is constant
Yeah.
for all the values. Okay.
So I think it's just those 3.
Yeah, I think so too.
Okay. 31.
It's the same question. They just asked us up there.
Yeah, but they bolded something, so that means it's different somehow.
Well, you read that one. I'll go up to read that one up there. Okay.
Pressures of supply and demand act directly on the price of airline tickets as the seats available on the plane begin to fill. Airlines raise the price. If seats on the flight do not sell well, an airline may discount the tickets or even cancel the flight. Allie Henrich, a BYU Idaho student, wanted to predict the price of.
Wanted to determine.
Now she wants to predict the price of tickets 14 days before a flight based on the
So
price.
we don't want to know the difference. We want to know.
The prediction.
We want to predict the price of tickets.
Yeah, listed 90 days before the same flight.
Predict.
So we'd open that document again, right?
Yeah. And then
What test would we do though to predict?
wouldn't it be the same one? It's asking for the sample correlation coefficient.
So it'd be the same test, just different.
Correlation coefficient.
Andrew, can you help them? They want the remote. What test did we say we were going to do with this one?
The paired sample t-test.
Oh, okay, yes.
You want to watch the show? You want to watch the show? You want to watch the show? Let's pick out a show tonight. That's the show. Show this how you go. Show this how you go.
How do we compute the sample correlation?
That's what I'm trying to figure out.
You know what? I wonder if we're using linear regression for this one.
Linear regression. That's true.
Because in the linear regression one, there's a coefficient.
Oh, then we probably are using that.
I just don't know which one's going to be what, though.
Linear regression.
Okay, Andrew and I did this last night. Wanted to predict. So one of them that you want to predict is going to be the explanatory, but I can't remember what's what. So let me go back to the book because we read over it. Where did I go? Where did my book go? Dang it. I got it. Okay, so.
So wouldn't the 14 days be predicting? That'd be.
Okay, so. About. Okay, right here. It says. Okay. So we use, which we can use to predict the value of y. X variable. What did we decide?
You were the one that decided it. I was confused. I think we said x fixed y is what we said.
Regression allows us to write a linear equation that models the relationship between independent x and the dependent y, which we can use to predict the value of y
So x predicts y.
for any given. So x predicts y, and
So I think X would be the 14 days and Y would be the 90 days.
so x is independent, which is explanatory.
Coefficient. But we find the coefficient for the slope or the y-intercept?
Well, okay. So of the price tickets for 14 days. I want to say it's for compute the sample correlation.
Compute the sample correlation coefficient. So would that be B1 then?
I think so.
So it would be 0.972.
I got. Well, wouldn't you go with the 0.084 because that's under the coefficient column? Well, I guess it's standard of error. I don't know.
Remember, he showed us which ones we used, and we used the bottom row. Is what he said.
Yeah, I use the bottom row, but do I use this column or this column?
Don't you use the first column under B? Because the second column is for the amount of error.
But look above that, it says coefficient.
But the coefficient's over B and standard error.
Okay.
So
Okay, and then it looks like.
So then would it be 0.972 for
Yeah,
3
I
days?
guess. Yeah, I don't know what else to. And then when you look at the scatter plot, I would say it's nonlinear, right? Because it's kind of like all over and on the ground. I don't know.
Yeah, that would be nonlinear. Well, I don't know, because would those be considered outliers?
But then would it be negative or positive?
That's true. Yeah, nonlinear. Okay, fill in the missing variables in the equation of the linear regression line used to predict the price of tickets. So, round to 3 decimals.
Kind of.
So for B0, I got negative 17.087.
Yeah. So then would the B1 for the slope be the same for 31?
Oh, that's true. Ooh, sample correlation coefficient. I'm kind of confused with 31.
Yeah, I don't know. We'll keep going. We'll see what it comes back. For y,
Okay, let's see. Y.
It's going to help right here. He pulls up this right here.
we're looking for the sample correlation coefficient.
Sample correlation.
Isn't there an equation to find y?
Yeah, it's in lesson 23, so I'm trying to go back to that right now. Okay.
Do you have the equation to find y in your notes?
Oh, yeah.
It's going to be in this other notebook.
Why is it zero?
You want to do that?
Let's be.
Right in here.
There's pen. Tell me what's right here.
What?
Let's be about
Negative 17.
negative 17.
0.087.
Okay. Which is
Point.
Did you guys find the equation for y?
Yeah, so it's
y equals b of o plus b of 1 times x plus e.
Plus e?
Yeah. They call it epsilon.
okay.
Really
So
okay.
plus 0.972
Times
times what?
which times x.
So would that be
X
x is 6
plus e.
plus 200?
200.
Yeah.
Wait, what would x be then?
It says on the Excel sheet 6, but I don't know. Did you write down what answer you got, Andrew? Right there? I got it.
Well,
I don't know. I just got a really good
well, let me see if you just do it this way.
So I got negative 11.255.
So what did you type in your calculator?
So I did negative 17.087 plus, and then in parentheses, 0.972 times 6.
Well, you got to do plus E, which is 200.
200.
Wait, because plus E, negative 11. So then after adding 200, I got 188.745.
That's what I got too, but Andrew got something different. So 188.725.
Yeah.
Why are we going with that one?
Because it's on.
I was going to do it a different way.
Okay.
So if I go equals, write down this number.
Right down right there. Okay, so then let's go on to number 35. I wrote down the confidence interval down at the bottom, not the ones up for the side.
So so it's 0.804 and 1.140.
Are those the ones that we use, or do we use the even like down at the very bottom where it says confidence interval for y, for mu?
Well, because this is asking for the confidence interval for the slope.
Oh, okay. Good catch.
Okay.
I don't know. I can try it again, Andrew. Will you try the equation again, Andrew? Keeps getting something else.
Yeah. Okay. Is he doing negative 17.087?
Yeah, he's just off by 5, so I don't know what he's doing wrong.
So we get 1.945 too?
No, they're off by about 5.
Okay, read me the equation that how you type it into your calculator.
Okay, I do negative 17.087.
0.87.
And then, was it plus or minus?
It's plus.
Plus, and then parentheses,
Why do you
0.972 times 6, end parentheses,
What?
200.
Why would you put that in parentheses?
Because you're multiplying it, so multiplication always has to come before addition.
Yeah, so don't you parentheses, you do a, so say it to me again, negative 17.087 plus 0.972.
No, plus parentheses 0.972 times 6, end parentheses, plus 200.
Yeah, I just typed it all in. Just typed it straight in. No parentheses, nothing, and I got the same thing.
So then it's 188.745.
Okay, perfect. Okay, so then I got number 35 right, or I got that fixed. And then it says choose the correct null and alternative hypothesis for this. Does the capital and lowercase matter?
Let's see. I don't know. They use the capital B in the book, so.
Okay. So then
So I think,
I would go with D, right?
yeah, I would go with D. The capital B1 equals 0, and then capital B1 does not
And
equal
then
0.
for t-test, is it for the slope as well?
Let's see, it says, it doesn't say for the slope, so, but I would assume it's for the slope because that's what we've been using, so.
Okay, so then did you get 11.514 or
Um,
512?
I got 11.512
Yeah,
in
sorry.
the Excel.
But then for the p-value, would it just be close to 0? Did that turn off?
Yeah, because it goes, yeah. So round your answers to 3 decimal places, so I just do 0.000.
Okay. And then it didn't give us a level of significance. Did it give us a level of significance? I didn't see it anywhere.
I think we can assume it's 0.05 because that's what it always is.
Okay.
So if it's less than, we reject the null. So there's insufficient evidence. So it would be D.
Okay.
Okay. So I'll read 39.
Okay, perfect. Thanks.
In the United States, mothers who live in poverty generally have babies with lower birth weight than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. The CDC carries out a study to test the effectiveness of a new prenatal care program in reducing the number of low birth weight babies born. For the study, 30 mothers of all whom live in poverty participate in the program and birth weight data is recorded. Which hypothesis test would be most appropriate for this study? So they're all in poverty.
Oh, gee.
You're comparing two.
I'm not good with stuff like this.
Yeah, we didn't do very good last
No.
time. First study.
Yeah, we did terrible on this last time. So they're trying to figure out if there's a lower birth weight in those who live in poverty versus not in poverty. So would it just be the paired sample t-test?
Yeah, I guess.
So C, because you're comparing them and you want to know if there's a difference or not. So the paired one will show the differences.
Or is it independent sample test? Because isn't the paired sample when you choose when they're dependent on each other? Like the one question that we had earlier with the husband and wife, I was talking about because we chose the husband, the wife was chosen. Isn't that a paired? That's paired because they come together.
But the paired sample shows the differences between variable 1 and variable 2.
But so does independent. They just
Wait,
independent does too. It just you choose your people differently.
okay, so maybe it's D, not C.
I don't know. I think it's one of those two for sure. I just don't know which.
Yeah, I don't know.
I'm trying to find it in the textbook. Inference for two proportion. It's not two proportion, one proportion. Inference for two means independent samples. Okay, so a paired data says, one example of a paired data is pre- and post-test scores, such as Mahone's weight loss study. So it uses the same person. So I don't think it'd be paired because it's not using the same person having a different result. You're comparing two people, right? So it says, in contrast to dependent samples, two samples are independent if knowing which subjects are in group 1 tells you nothing about which a subject will be in group 2. And that's what we're at, right? With independent samples, there is no pairing between the groups. Suppose you want to compare the incomes of men and women in the general population. A random sample of men would be collected, and each would be asked to report their income. Similarly, a random sample of women would be drawn, and they would also be asked to report their income. So in this question, whatever question it was. So yeah, you're taking, I think it's,
Yeah.
I think it's D from
Yeah.
those readings. Because they don't tell, choosing one doesn't tell us anything about the other. Okay, so 40 is engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of the vapor pressure of the gasoline made by the refinery is always 0.03 pounds per square inch. Which hypothesis test would be most appropriate for the task?
Well, wouldn't it be A or B?
One sample Z test, one sample T test.
Yeah, so you know your standard deviation because it says the standard deviation of vapor pressure of the gasoline made by the refinery is always that. So it would be
So, A.
A.
An attorney wants to know whether the percentage of Walmart employees in Nevada who are over 40 years old is more than 30%. What procedure would be most appropriate for this solution? Wouldn't it be F, one test of
Yeah,
of
one proportion. Then 42, a marriage counselor conducted a study of couples, categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples chose marriage ended in separation of divorce or divorce. Which hypothesis test would be most appropriate of this study? So would it be chi squared since there's multiple variables?
Okay, so you have communicative, non-communicative.
And then you have
Also wanted to
the
see
married ones that are divorced and then not divorced.
and among the things the council wanted to see whether the percentage of communicative couples
Yeah, I think
was
it's
marriage ended in separation of divorce. Yeah, that sounds good to me.
Okay.
So H.
Yeah.
A business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between sales and the amount of money a client invests in the radio advertising. Which procedure is the best? Is the list above would be most appropriate for addressing this question?
Wouldn't it be linear regression? Because they want to see a linear relationship.
Yep, I think so.
Okay.
Okay,
I don't have any of these answers since we're
So there was one in the beginning that we didn't know about. It was number 6. About the LSAT scores.
Hmm. Let me
And
go.
that was...
Okay, so we had this exact same question in homework lesson 5. And, no, one similar, oh yeah. Okay, so it says find the 35th percentile of the LSAT score. And somehow we got it right, and it was 146.8.
So I know there's an equation with that. I think it's the one we use later where you do the value minus the mean divided by standard deviation.
Okay, yeah.
Yeah.
Also, we had the number 5, and I think that 95 is going to be correct.
Okay.
Because we put 99.7 last time, and we got it wrong.
Yeah, so it should be the 95 since it's 2 standard deviations. Sorry.
Let me just double check on... Did we have any other questions?
Not that I can think of right now. But
Okay, there was a dermatologist one right there. It's approximately normal. For number 7, I think it's going to be normal.
excuse
Well,
me.
actually, no, maybe not. No, leave it. Sorry.
What?
Because this doesn't say anything about 2. Oh. It says that, although in 10 it says, suppose the sample size of the study was 2 instead of 70, which shape would it be? It says right skewed. I think 7's right skewed.
Okay. There was another one I remember. It was the 4 divided by 5 one with the p hat.
Oh, okay, yeah. We don't have
Yeah,
that.
number 20.
So will you look why I'm gonna do this real quick? I have to keep looking to make sure if there's any. You know, let me do. Can you go to P hat? Look it up, see if you can. Lesson 16 or 17.
Which is it? 16 or 17?
So I think 20, maybe 20 is 2, and if we use that equation, n times p is equal to or greater than 10, because, let's see, 4 divided by 5, 0.8.
No.
Hey, Kaden, please don't make a mess. We're gonna go night-night in just a minute, okay?
Jump. Ready? Jump. Jump. So we got this. This is the only one that we got right there. It says to type
You already submitted it? I don't know what.
suppose p equals 1/2. What is the smallest n can be, and both requirements still met? This talks about p rather than p.
Yeah, I don't know what the requirements for P hat are. That's what we need to know. What are the requirements for P hat?
Did either of you submit it yet?
No.
Because 20, maybe 20 is just 5. Maybe we're trying to overthink it or something, I don't know. Because p hat equals x over n, and they're saying p equals 4 divided by 5, and p hat is a sample of p. So maybe it's just 5.
So the smallest that P hat can be is 5.
Yeah.
P equals 4 over 5. What is the smallest value of n that satisfies the requirement for normally distributed p? It says your estimate for the true proportion p becomes p tilde. That's p tilde. So p hat estimated proportion equals x over n as long as right here, does this mean anything?
I don't know.
Right here.
I'm thinking we have to submit it. Yeah, as long as, yeah.
Because
So it'd be 7. N equals 7.
N equals 7?
Yeah, because if you go, well,
why 7?
oh, 5. Okay. So does it have to equal once you
So
times
as
that?
long as n is greater than or equal to 5.
Okay, so then 5. Okay.
So N is 5.
Yeah.
Okay.
True. A. 4A, 595, 6, 1.6,
Okay.
7 minus 2, 8, 2.236, and negative 2.357.
For what?
8, 9. Negative 2 point
No.
9, 9.
1. Okay, where's your blanket?
10 is A, 11 is B, 12A, 13, 0.128,
Okay.
14 B, 15, 0.096, 16 C, 17 B, 18 A, 19,
No. 18 is C.
19
Is B.
B, 25, 21 is
D.
D,
22 D.
22 B, 23, 0.101,
Yeah.
24.191,
Yeah.
any M will do,
D.
or
B. B.
28 B,
Yeah.
29,
C.
and then I think I got those ones right, and then 31, 0.972,
0.84.
32,
Wait. 0.0.
0.084,
Yeah.
32,
Here.
nonlinear.
Sorry, Amanda, we're just going over them real quick.
Okay, it's okay.
Four, 36, 37, 38, 39, 40. Okay.
Oh, we didn't do so well.
Really?
Yeah.
What did we get wrong?
Well, a lot of them. We got 3 wrong.
3?
Yeah, 3, 4, 5.
Wait a second.
11, 13, 20, we got wrong. 24, 31, 32, 33, 34, 35, 37, 38, 39, and then 42.
Okay, so
Retake it.
okay, let's try to figure out.
Just showing us video.
So number 3.
How many prompts did we get wrong? We're only learning one.
Number 3 would have to be an observational study then,
We don't have
because they don't have control.
I don't know. I'm sorry, are you going
over-
number 3?
Yeah, number 3, I would say it's D then.
An observation.
Can you guys hear me?
Yeah.
Okay.
Um,
And then 4, wasn't that in a past quiz or something?
should we just say the median will stay the same?
Maybe it's D, that it's not possible to determine it without a full data set.
Oh, yeah, that's probably what it is. Because look at those little dots. That means there was more than, it wasn't just those. There was actually 100 students. So, yeah.
So then 5 would have to be 68.0. If it's not 95 and it's not 99.7.
Let's not go. Oh. I thought you said you had that one.
What, 11? No.
Wait, so we got 3, 4, 5, and then we
8.
got 6 through 10, right?
Yep. No, you got 8 wrong.
8?
You got 8 and 11.
We got the z-score wrong.
So there's gotta be another.
8,
I'm just
5.
gonna skip that one and go to 11.
Maybe 8 we don't use the 8550. Maybe it's just
Yeah, I don't know.
8544 divided by 12 with the square root of 20. So that doesn't make sense though. No. Maybe, do we need to, I don't know what to do for 8. It's like 8,
Yeah, I don't know what to do with that one either.
then 11, that means it's probably A and B
Yeah.
instead of just B. And then
Yeah, so what I think we did is we put the information in wrong. Therefore, we got out.
Do you want to raise and do it or just leave
I
it?
closed everything since I have to reopen that.
So what's the next one? Which ones did we get wrong on the last one? Just 40, 39, and
42. I think we must have put the information wrong.
for 13,
No, 31 through 37, 38. I can do it just so you can try it. Oh, I guess it's hold on.
Wait, for...
Yeah, 39 off. So maybe it is 30.
We'll try.
42, H, squared 10.
Wait a second. So 31 and so on, we put the information in wrong, or?
Yeah, I'm guessing because we got them all wrong.
Should I submit mine?
No, I'm gonna fix this. I just pulled all the
You
stuff
can
right.
retake it.
Yeah, but I might as well check. It's already up. Just yeah, but then we don't have to complete all the answers. So right now, if we did it right, or if I need to find another solution.
So for that one, we used linear regression, right?
Yeah.
So maybe we're supposed to switch the two sides?
Right. I think that we need to do the 14 in the other side and the 90 in the other side.
Okay, I need to reopen that document. Data files. Direct. So the explanatory will be the 90-day. So then if we switch that,
Hold up so that I can put it in. 31.
the correlation coefficient would be 0.627.
But didn't yeah, I guess.
It's still non-linear.
No, I would say that linear
Because it has shape pattern.
with a fairly B.
So then, since there's some outliers,
I would go with B. It's fairly strong positive association.
Which means that
what's the difference between negative and positive again? Negative, positive.
Keep going with the 30.
33.
Yeah.
Which is
115.6.0. I can't remember the difference between positive and negative.
Okay. So then for B0, did you guys get 115.640?
Yeah.
And then for B1, 0.627?
Yeah.
Okay. And then that means Y is
0.
5 point.
5-4. Because so then we gotta do the Y.
34.
We go to 35 and
34. Yeah.
No, we have to do the calculation, which I'm going to do in a minute. 0.518.
Okay, so then for 34, for y, I got 319.402.
So, sorry, let me write that really quick. What did we say it was? Yeah, you got 319.384.
No, I got 319.402. Because you put x equals 6, right?
Yeah.
Okay. And then you add 200.
Okay, yeah, 319.402.
Yes.
Okay. And then your t-score would be 11.
Even.
11.510.
Zero.
Oh, because I don't know. Okay, yeah, can do 0.
What does it say?
What? It
38
says,
we got wrong too.
yeah.
Oh, what it says it's not p-value.
Wait, but we got 38 wrong, then we got the p-value wrong.
Right.
Because when you recheck, there's sufficient.
Oh, it's because when you reject, there's sufficient evidence.
So you fail to reject, there's
Which
Oh,
is,
yeah, that's right.
okay, now, can you submit it?
I changed these two.
Okay, perfect.
And then 39, if that's not D, would it be C?
Yeah.
That's what
And then we also got 42 wrong, so Andrew put G.
I have no idea.
Test of two proportions.
But yeah, just submit it and see what happens. You can retake it.
With the 4, test of two proportions.
Okay.
Okay,
So we got a C plus, which is a lot better. Can you give me these? Like a new test.
Okay, so what did we get wrong this time?
Okay.
Well, you just skipped one that you got wrong.
What?
3.
Oh, 3 is still wrong.
Did you put D for 3?
Yeah.
So then it has to be C because it's not A and it's not D and they don't have control. Okay.
I think it's A or B because what do they
It's
have?
A for what?
No, B. I mean, because the students had control over which cereals would be selected. They had control over.
Well, they rolled a die to decide which box, so they didn't have control. The die had control,
Okay, so
right?
Where?
yeah, B would make more sense than C, I guess, with the prices.
C.
So I'll go with B. I'll see what it says.
Yeah.
That's good. Just tell her all the ones you have wrong.
Um.
We still got 5 wrong.
So the only thing
Really?
left is 99.
No, we tried that in the other one. In our other homework assignment. So I think we're doing it wrong.
Well, it said to do 1 decimal place, so should I just try it without the decimal place?
That's fine.
Um,
That's good.
So then, did we get 11 right with A and B?
I don't know. I did A, B, and I did D. So I'll
Oh,
probably, you just do A and B and
okay.
then see if that works. Because you'll for sure get at least a 77. So
scroll down.
Then, I never changed 13. I don't know if you did, but...
No, Andrew didn't either. Okay, keep going, Andrew. Going
What
down.
about 20? Did you put 5 for 20?
I put 1 for 20,
Oh.
and I'll see if I got it right. No, I put 5 for 20 last time. I got it wrong, and I put 1 for 20 this time and got it wrong. I have no idea.
Hmm.
Okay, 17.
Let's see. Yeah, I put 1 for 20 and got it wrong. I have no idea.
Okay, then I don't. Yeah, I'm just gonna leave that.
20 is B.
What?
20, 21 is B. B. 0, 1 is B.
Then, wait, what do we need to do for 24? Did you say we got 24 wrong?
Yes, we did. I don't know.
I did this one. I did this one.
Yeah, so it's either gonna be A or C.
Okay.
What's 25, Andrew?
And then we got 25 through 30 right. Right?
Sorry, we're getting there.
Okay.
Okay, yeah, so we still got 31 wrong.
Oh, I don't think I changed that. Wait. What? Linear regression?
Oh,
You might.
you might get it right.
I put in a different number, I think.
Oh, wait, you didn't put 0.627?
No.
Oh, okay.
Yeah, so it might be that.
Okay, 32. Did you put B?
Yeah. And 33 is right.
So 32 you got right?
Yeah, 32 and 33 is right.
34 we still got wrong.
Maybe we're supposed to do it without adding the 200? Or maybe 6 is not. I
don't know. Maybe it's not 6, but I don't know what it would be, though.
Yeah. Well, if I do 1, 1. What does X even stand for? Does it say?
We couldn't figure we didn't find it.
Let me go to my notes. I might have put it in there. Okay, X. X's are fixed and measured without error. Doesn't say what it is.
What do you think this one is? What did you try? C?
Yeah, before that we tried D.
Maybe I'll try B. I don't know.
Can't be one. It's gotta be a Nova if it's got one test of one proportion. Maybe this one's test of two proportion. No, I'm done.
B.
Are you gonna have to look at that?
So if it's the fixed, well then what would E be?
Wait, so then we got 34 wrong, but we got 35.
Yeah, we got all the rest
35
of them right,
right.
other than 39.
39? What the? Okay, so they're comparing mothers who live in poverty versus not in poverty.
Okay, so get 3 wrong. Oh, you can only take it 3, take it 1. If you want. I guess you could. Yeah. Okay. You can retake it 1.
Okay, I just submitted it. Let's see. 3 is still wrong, so 3 is C.
Yeah.
5 is wrong. I just put 95, didn't do a decimal. 8 is wrong. 11 is wrong, so it's not A and B. 13 is wrong. 20 is wrong. 24 is wrong. So that means it's C, because I put A.
For which one?
24 has to be C.
Okay. Yeah, because I put A2 and I got it wrong. Which one were you on?
Okay, 31 is wrong. Did we change that at all?
No, I don't think so.
Okay. 34 is wrong. I don't know how to do that. And
Did you get 11?
It's not A and B.
11. Yeah, I just know I put A and B and I got it wrong.
And what did we do the first time? Just B?
The first time we just did B.
What if I just do A this time?
Okay. Well, hopefully the test isn't this hard. Oh.
Yeah.
Do you have any other questions, Amanda?
Nope, I do not. Did you guys try retaking it already?
Yeah. You can only retake it once.
Oh, okay. Are they just in the same exact order?
Yeah.
Okay.
They are.
Okay. Yeah, I don't have any more questions. I feel like the test is gonna be really hard, but um so then are we meeting tomorrow for our last time?
Yeah, it's gonna be open, right?
Yeah, it'll be open. I looked at the time. It should be open at 6 a.m. tomorrow.
Okay.
Um, so since it's technically scheduled for next week, I can be the group leader and I'll email you guys the PowerPoint tomorrow before the meeting so that we can just go over that in the meeting because I think that's all we need to do for our last meeting.
Okay. Perfect. Sounds good.
Okay. And then I'll just send a text to Andrew's cell phone once I have it sent to you guys so that you can look it over before the meeting.
Okay. Awesome.
Okay. And do you guys just want to meet at 9 o'clock Mountain Standard Time tomorrow?
Yep, that works for us.
Okay. Cool.
So, alrighty. We will see you tomorrow.
Okay. Sounds good. Bye.